Hey students, welcome to my channel. The channel provides you a series of video classes on each chapter of class 11 and class 12 chemistry. These are uploaded in two modes: classroom learning type, NEET bar JEE main preparation type. Classroom learning type videos include a detailed description of the topics concerned, while the other include an abridged version with well explained question and answers including previous year's questions. By the way, I am Dr. Sirik Matthew, a retired professor in chemistry. The purpose of my channel, Chemistry Master, is to upload video classes related to NEET, JEE Main and Advanced, KEEM, CVT and other competitive examinations. We start with basic concepts of chemistry, the first unit of class 11 chemistry. Other chapters will follow in a time-bound manner. This is part 1 of the abridged video series meant for NEET and JEE main candidates. The remaining parts will be uploaded soon. The links to other videos are given in the description part of this video. If you like the video, please subscribe my channel and forward to others. We start with precision and accuracy. Scientists typically make repeated measurements of a quantity to ensure the quality of their findings and to know both the precision and accuracy of their results. Look at this dartboard. The yellow disk is the target. Darts hitting the yellow disk will be accurate. These three blue dots are outside the target, so they are not accurate. Moreover, they hit places far apart from each other. That means the repeated attempts do not yield the same result. This indicates that these are not precise. They are neither precise nor accurate. Measurements are said to be precise if they yield very similar results when repeated in the same manner. All the three yellow dots hit the target, so they are accurate. Moreover, they hit places very near to each other. That means repeated attempts yield nearly the same result. Hence, yellow dots are precise and accurate. A measurement is considered to be accurate if it yields a result that is very close to the true or accepted value. The three red dots are outside the target, so they are not accurate, but they hit the nearby places. That means repeated measurements give almost the same result. So we can say these dots are precise but not accurate. Precise values agrees with each other, accurate values agree with the true value. Temperature is a familiar word commonly used in our day-to-day life. It measures the intensity of heat, the hotness or coldness of a body. A piece of metal at 60 degrees Celsius feels hot to touch, whereas an ice cube at 0 degrees Celsius feels cold. Heat is a form of energy that always flows spontaneously from hotter body to colder body, and never in the reverse direction. Temperatures can be measured with mercury in glass thermometers. There are three common scales to measure temperature. One is degree Celsius, second one is degree Fahrenheit, and Kelvin. Kelvin is the SI unit. This is a mercury in glass thermometer. In the Celsius scale, the freezing point of water is taken as 0 degrees Celsius and boiling point of water is taken as 100 degrees Celsius. In the Fahrenheit scale, freezing point of water is 32 degrees while boiling point of water is 212 degrees. In the Kelvin scale, freezing point of water is 273 Kelvin while boiling point of water is 373 Kelvin. Room temperature is 25 degree in Celsius scale and 77 degree in Fahrenheit scale. In the Kelvin scale, it is 298 Kelvin. We can interconvert degree Celsius to Fahrenheit or Fahrenheit to degree Celsius or degree Celsius to Kelvin. Degree Fahrenheit is equal to 9/5 into temperature in degree Celsius plus 32. Degree Celsius is equal to temperature in degree Fahrenheit minus 32, the whole multiplied by 5/9. Kelvin is equal to degree Celsius plus 273.15. We shall usually round 273.15 to 273. We know every experimental measurement has some amount of uncertainty associated with it because of the limitation of measuring instrument and the skill of the person making measurement. This is indicated by means of the significant figures. Significant figures are meaningful digits which are known with certainty plus one which is estimated or uncertain. An exact number may be thought of as containing an infinite number of significant figures. For example, 1 dozen x, that is 12x. There are 12 x, nothing more, nothing less. For a detailed description of significant figures, refer my video Basic Chemistry Classroom Learning Part 1. The link to the video is given in the description part of this video. Now consider a measured quantity. For example, 0.005003600 gram. This zero is not significant. This zero is used for a decorative purpose, that is not to start with the decimal point. These two zeros are also not significant because the zeros used only to locate the decimal point. These three digits are significant because they are non-zero integers. Now these two zeros, they are also significant because they are zeros between non-zero integers. And these two zeros are also significant because zeros at the end of the number towards the right of the decimal point. So for this measured quantity altogether, there will be 7 significant figures. 1, 2, 3, 4, 5, 6 and 7. Let us see some examples. Example 1, 98.62 gram. There are 4 significant figures. All are non-zero integers. Second one, 200 ml. There is only one significant figure. These two zeros are not significant. Next one is 0.0044 gram. Here we have only 2 significant figures because these 3 zeros are not significant. Now this number 902.10 gram. Here this zero also is significant. So altogether there will be 5 significant figures. So this one is a scientific notation and here we have only 3 significant figures. Now 200.0 gram. Now this zero is significant because it is towards right of the decimal place. So total there will be 4 significant figures. 0.1357 gram. There are 4 significant figures. This zero is not significant. 6.200 gram. All the 3 zeros are significant because they lie towards right of the decimal place. So total number of significant figures are 5. 6.02 into 10 raised to 23 atoms. This is a counting number, so it will have infinite number of significant figures. 400x, that also is a counting number, and it has infinite number of significant figures. Very often we need to round off numerical results. If the rightmost digit to be removed is more than 5, the preceding number is increased by 1. For example, 1.386. If we have to remove 6, that is this one, we have to round it to 1.39. 8 increased by 9 because 6 is greater than 5. If the rightmost digit to be removed is less than 5, the preceding number is not changed. For example, 4.334. If 4 is to be removed, then the result is rounded to 4.33. If the rightmost digit to removed is 5, then the preceding number is not changed if it is an even number, but it is increased by 1 if it is an odd number. For example, if 6.25 is to be rounded off, it is rounded off to 6.2 because the number to be removed is 5 and the next number is 2, which is an even number. The preceding number is an even number. On the other hand, if 6.35 is to be rounded by removing 5, we must increase 3 to 4, giving 6.4 as the result. Let us consider some examples. Round off the following measured values to 4 significant figures. First value 3984.6 gram. We have to round off to 4 significant figures. We need 4 significant figures up to 4. So the last digit to retain is 4. and the digit to be dropped is 6 and it is greater than 5. So 4 increases by 1. So the rounded off value will be 3895 gram. 4 significant figures are there. Second one, 422.04 gram. So the last digit to be retained is 0. That means so that there will be 4 significant figures and the digit to be dropped is less than 5. So it remains as such and there are 4 significant figures. Then another one, 4854.5 gram. The last digit to be retained is 4 and the digit to be dropped is equal to 5. Since this is an even number, it will remain as such. And again 4 significant figures. And here it is 3985.5 gram. The last digit to be retained is odd and the digit to be retained is equal to 5. So it increases by 1. So the rounded off value is 3986 gram. Again 4 significant figures. First we have to write this number in the scientific notation, that is 3.390, so that we get 4 significant figures. Now this number, the last digit to be retained is 7, so that the number of significant figures is 4 and the digit to be dropped is 2, which is less than 5, so it remains as such. 5.047 into 10 raised to minus 4 mole and 4 significant figures are there. Now let us learn how we use significant figures in numerical calculations. First we consider addition and subtraction. When we add or subtract numbers, we should round the result to the same number of decimal places as the number with least number of decimal places. Remember, in addition and subtraction, we consider the number of decimal places. Once again, when we add or subtract numbers, we should round the result to the same number of decimal places as the number with the least number of decimal places. That is, the least precise value in terms of addition and subtraction. For example, let us consider the following addition: 1.0056 gram plus 2.32 gram plus 4.5 gram. The first measured value has 4 decimal places, second 2 and third only 1. Now when we add this, we get this result. The least precise value is 4.5, which is having only 1 decimal place. So the result must be in 1 decimal place. So we have to retain only 8. Since the number to be dropped is less than 5, it remains as such. The value will be 7.8 gram. Now let us consider subtraction. 584, no decimal place, minus 526.24 gram. The result is this one. So here we have 2 decimal places. But the least precise value is this one. So the result also should not have any decimal place, that is, it should be only in ones. So we have to retain this 7 and the digit to be dropped is 7. It is higher than 5, so it increases by 1 unit. So the value will be 58 gram. Now let us see multiplication and division. When we multiply or divide numbers, we should round the result to the same number of digits as the number with the least number of significant figures. That means the least precise value in terms of multiplication and division. For example, consider this multiplication: 15.65 centimeter multiplied by 14.85 centimeter, again multiplied by 5.05 centimeter. This is the result. So it is centimeter cube. The first value has 4 significant figures, second 4, but the third has only 3 significant figures. So the result must be in 3 significant figures. So in order to write this in 3 significant figures, we have to express it using scientific notation. When we write in scientific notation, it becomes 1.17 into 10 raised to 3 centimeter cube. That is, we are having only 3 significant figures. Now division. 426.46 gram divided by 482. So the result is 0.8848 gram per ml. The number of significant figures for the denominator is 3, while that for the numerator is 5. So the result must be in 3 significant figures. This one. that is 5 significant figures by 3 significant figures, the result must be in 3 significant figures. Dimensional analysis. While doing calculations, very often we need to convert units from one system to another. The method used to accomplish this is called dimensional analysis. It provides a systematic way to convert units from one system to another. For example, meters to feet, kilograms to pounds, etc. For that, we need to construct unit factors. In dimensional analysis, we first construct unit factors from any two terms that describe the same or equivalent amounts of whatever we may consider. For example, 1 meter is equal to 100 centimeter. The right hand side and left hand side are the same. Now we divide both sides of this equation by 1 meter. Then we have 1 meter by 1 meter equals 100 centimeter by 1 meter, or 1 is equal to 100 centimeter by 1 meter. So this term is a unit factor. This is unit factor since numerator and denominator describe the same distance. So multiplication by this factor is same as multiplication by 1. Similarly, if we divide the first equation by 100 centimeter, we get 1 meter by 100 centimeter and 100 centimeter by 100 centimeter, or 1 meter by 100 centimeter is equal to 1. And this also is a unit factor, and it is the reciprocal of the first one. Next, we will study the laws of chemical combination. The first one is law of conservation of mass. The law was put forward by Lavoisier in 1789. He conducted many combustion experiments and was convinced from those experiments that oxygen from air is essential to combustion. This also led him to formulate the law of conservation of mass. That means during chemical reaction, the total mass of the products formed will be same as the total mass of the reactants taken. Or in other words, matter can neither be created nor be destroyed. The second law is law of definite proportion. It was proposed by Joseph Proust in 1779. The law could be stated like this. A given compound always contains exactly the same proportion of elements by weight. That means all samples of a compound have the same composition, that is, the same proportion by mass of the constituent elements. As an example, let us consider copper carbonate. The elements are copper, carbon and oxygen. Copper carbonate can be obtained from natural sources as well as by synthetic method. Suppose we analyze copper carbonate and we find out the percentage of copper, carbon and oxygen. The natural sample contains 51.35% copper, 9.74% carbon and 38.91% oxygen. Then another sample which is obtained synthetically, and upon analysis that also gave 51.35% copper, 9.74% carbon, 38.91% oxygen. That means all samples of copper carbonate contain the same composition, that is, the elements in the same composition. The third law is the law of multiple proportion. It could be stated like this. If two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers. Based on his atomic theory, John Dalton proposed the law in 1803. We will explain this law while doing problems related to this law. The fourth one is Gay-Lussac's law of gaseous volumes. At constant temperature and pressure, the volumes of gases that react or are formed can be expressed as a ratio of simple whole numbers. For example, the reaction between hydrogen and chlorine forming hydrogen chloride, 1 volume of hydrogen plus 1 volume of chlorine gives the 2 volumes of hydrogen chloride. So, there is a simple ratio between the volume 1:1:2. Gay-Lussac's law does not apply to any solid or liquid reactants or products that may be present. Then fifth one is the Avogadro's law. Equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. We can state the law in another way also. Equal numbers of molecules of different gases at the same temperature and pressure occupy equal volumes. We will further explain these laws while doing problems connected to these laws. Now let us discuss Dalton's atomic theory. In 1808, John Dalton, an English school teacher, tried to explain why matter behaves in such systematic ways as revealed by the first three fundamental laws of chemical combination that we have already studied. In line with the suggestions made by Democritus, he proposed his atomic theory based on experimental observations. His theory involved the following assumptions. First one, each chemical element is composed of minute, indivisible particles called atoms. Atoms can neither be created nor be destroyed during a chemical change. Second one, all atoms of a given element have identical properties, including identical mass at that time weight. Atoms of different elements differ in mass. Third one, compounds are formed when atoms of different elements combine in a fixed ratio. For example, one atom of A to one atom of B, that is AB, or one atom of A to two atoms of B, example AB2. Chemical reactions involve reorganization of atoms. Even though Dalton's theory could explain the laws of chemical combination, it could not explain the law of gaseous volumes. Dalton did not consider the existence of molecules. Also, his theory could not explain why atoms combine. Let us work out some multiple choice questions related to precision and accuracy, significant figures, and laws of chemical combination. Question 1. Using the rules of significant figures, the correct answer for the expression, that is, a multiplication and division, will be option 1, option 2, option 3, and option 4. Here first we have to multiply the numerator. For multiplication of the numerator will give a result with the 3 significant figures. So here this number is having 4 significant figures, while this one is having 3 significant figures. So since it is multiplication, we have to choose the least precise value. So the numerator will have 3 significant figures. Now the denominator is having 4 significant figures. So 3 significant figures by 4 significant figures, the answer should be in 3 significant figures. So we have to choose the option which is having 3 significant figures. Here it is 4, now here it is 3. Option 2 is the correct answer. Here the number of significant figures is 2 and here it is only 1. So the correct answer is 0.00561. Now the second question, using the rules of significant figures, the correct answer to the expression 1.0056 plus 4.5 divided by 14.75 will be option 1, option 2, option 3 and option 4. Here addition and division. And in addition, we consider the number of decimal places. This number is having 4 decimal places while this is having only 1. So this is the least precise value. Therefore, when we add, we get this quantity. So when we write it in 1 decimal place, we have to drop numbers beyond 0. So it is 5.5. Now the division 5.5 by 48.75. The number of significant figures here is 2, numerator, and for the denominator it is 4. Since the numerator is having only 2 significant figures, the answer should be in 2 significant figures. So we drop 2. So the answer is 0.11. The correct option will be the fourth one. Question 7. Cesium atoms are the largest naturally occurring atoms. The radius of a cesium atom is 2.65 angstrom. How many cesium atoms would have to be laid side by side to give a row of cesium atoms 1.00 inch long? Assume that atoms are spherical. Given that 1 inch is equal to 2.54 centimeter and 1 angstrom is equal to 10 raised to minus 8 centimeter. Option 1, option 2, option 3 and option 4. Now first we have to construct the unit factors. And before that, what we have to find out is, suppose these are cesium atoms. Now this distance is 1 inch. We have to calculate the number of cesium atoms that are present in this much distance. And the diameter of a cesium atom is 2.65 into 2, that is 5.30 angstrom. So the radius of the cesium atom is given, and the radius into 2 is diameter. It is given that 1 angstrom is equal to 10 raised to minus 8 centimeter. So we divide it by 1 angstrom, that is 10 raised to minus 8 centimeter by 1 angstrom is equal to 1. So this is 1 unit factor. Similarly, it is given that 1 inch is equal to 2.54 centimeter. So we divide by 2.54 centimeter, 1 inch by 2.54 centimeter is equal to 1. That is the second unit factor. First we convert angstrom to centimeter. How many cesium atom would have to be laid side by side in a row of cesium atoms of 1 inch long? Now the diameter of one cesium atom, that is this much distance, and that is 5.30 angstrom. So we multiply by this unit factor, this angstrom and angstrom cancels, and we get the diameter of one cesium atom as 5.3 into 10 raised to minus 8 centimeter. Now we need to convert this into inch. 5.30 into 10 raised to minus 8 centimeter. So we can use this unit factor to convert centimeter to inch. That is 1 inch by 2.54 centimeter. Centimeter and centimeter get cancelled, and what we get is 2.09 into 10 raised to minus 8 inch. That is the diameter of a cesium atom, that means this much distance, is 2.09 into 10 raised to minus 8 inch. Now we have to find out the number of cesium atoms in 1 inch. Diameter of cesium atom is 2.09 into 10 raised to minus 8 inch. To find out the number of cesium atoms in 1 inch, we divide 1 inch by the diameter of one cesium atom. So the answer is 0.478 into 10 raised to 8. Or in scientific notation it is 4.78 into 10 raised to 7 atoms. So the correct option is option 4. Question 8. The absolute zero of temperature is 0 Kelvin. In degrees Celsius unit, which one of the following is the absolute zero of temperature? Option 1, option 2, option 3 and option 4. We know minus 273.15 degrees Celsius is absolute zero. Question number 9. The number 0.0120 when written in scientific notation is option 1, option 2, option 3 and option 4. We move the decimal place 2 places towards right. So the answer is 1.20 into 10 raised to minus 2. Question 10. In which of the following all zeros are significant? Option 1, option 2, option 3 and option 4. In the first one, these 4 zeros are not significant. In the second one, these 2 are not significant, but these 2 are significant. In the third one, all the 4 zeros are significant. This 0 is significant, and these 3 zeros are also significant because they are towards the right of the decimal place. So the correct answer is option 3. The next question is an assertion reason question. Assertion A. Significant figures for 0.200 gram is 3, whereas for 200 gram it is 1. Reason: 0 at the end or right of a number are significant provided they are not on the right side of the decimal point. Option 1, option 2, option 3 and option 4. The assertion is correct. So number of significant figures here is 3 and here it is only 1. But the reason is wrong. And zeros at the end or right of a number are significant provided they are not on the right side of the decimal point. If they are on the right side of the decimal point, they will be significant. So A is true, assertion is true, but reason is false. Question 12. Which of the following best defines accuracy? 1. The closeness of repeated measurements to each other. The number of significant figures used. The closeness of measured to the true value. The smallest unit a measuring device can detect. So which of the following best defines accuracy? Accuracy is the closeness of a measurement to the true value. That is the correct option. Which of the following best define precision? 1. The closeness of a measurement to the true value, the number of decimal places used, the repeatability of measurement, the ability of an instrument to measure quickly. So precision is the repeatability of a measurement. So option 3 is the correct answer. Question number 14. A student perform an experiment 3 times and records values as 9.8 meter per second, 9.9 meter per second square, 9.7 meter per second square. The true value is 9.81 meter per second square. What can be said about the measurements? 1. Accurate but not precise, precise but not accurate, neither accurate nor precise, both accurate and precise. Here the measurements are very close to each other, 9.8, 9.9 and 9.7. So we can say that these measurements are precise. Now the true value is given and true value is 9.81 meter per second square. So therefore these values are very close to the true value. So these measurements are accurate also. So the measurements are both accurate and precise. Next one, if an instrument gives the same reading each time, but the reading is far from actual value, the instrument is accurate and precise, precise but not accurate, accurate but not precise, neither accurate nor precise. When the instrument gives the same reading each time, that is repeated measurement gives the same reading, but the reading, all the readings are far from actual value. So it is precise but not accurate. By heating in a current of hydrogen, 2 samples of lead oxides were separately reduced to metallic lead. The mass of lead obtained from one oxide was found to be half the mass of lead obtained from the other oxide. The data illustrates one law of reciprocal proportion, then law of definite proportion, the law of multiple proportion, the law of constant proportion. Two compounds with the same elements, but the amount of one element combined with the fixed weight of the other is different. So this explains the law of multiple proportions. Hydrogen gas and oxygen gas combine to form water. They combine in the ratio 2:1. This is explained by the law of reciprocal proportions, law of multiple proportion, Avogadro's law, Gay-Lussac's law of gaseous volume. In gaseous reactions, gases combine in simple ratio. So here hydrogen and oxygen combine to form water. The ratio is 2:1. So the law explained is Gay-Lussac's law of constant volume. Question 18. Which of the following laws of chemical combination is followed by the set of compounds N2O, nitric oxide and N2O3? 1. The law of multiple proportions, law of conservation of mass, the law of definite proportions, Gay-Lussac's law of combining volumes. We have N2O and NO can be written as NO twice, that means N2O2. That is, NO can be considered as N2O2. The other one is N2O3. In all these cases, the amount of nitrogen is the same, N2, N2, N2. But the amount of oxygen varies. 1 oxygen here, 2 and 3. So the different elements combined with a fixed amount of the other bear a simple ratio. Therefore, these 3 compounds explain the law of multiple proportion. Which of the following reaction is not correct according to the law of conservation of mass? Option 1, option 2, option 3 and option 4. So in the second one, then here there are 3 carbon atoms, but here only 1. So this equation is not balanced. Therefore, option 2 is the correct answer. The number of atoms of each kind on either side are not the same for option 2. For mass is not conserved. Question 20. The following data are obtained when gaseous nitrogen and gaseous oxygen react together to form different compounds. Mass of nitrogen, mass of oxygen. In first compound, 14 gram nitrogen combines with 16 gram oxygen. Second one, 14 gram nitrogen combines with 32 gram oxygen. Third one, 28 gram nitrogen combines with 16 gram oxygen. Fourth one, 28 gram combines with 80 gram oxygen. Now the options are law of conservation of mass, law of definite proportion, Avogadro's law, and the law of multiple proportions. Now let us consider the first one. 14 gram combines with a 16 gram. Second one, 14 gram combines with a 32 gram. Now in the case of third one, 28 gram combines with a 16. Or we can say that 14 gram combines with 8 gram. So 14 gram combines with 8 gram. And the last one, 28 gram. So we can write it as 14 gram combines with 40 gram. So we keep the masses of nitrogen constant and the masses of oxygen combining with the fixed mass of nitrogen are different. Here there exists a ratio that is 2:4:1:5. For different mass of oxygen combined with a fixed mass of nitrogen bear a simple ratio. So the answer is the law of multiple proportions. Question 21. Dalton's atomic theory could not explain which of the following? 1. Law of conservation of mass, law of constant proportion, law of multiple proportion, and a law of gaseous volumes. And Dalton's theory could not explain the law of gaseous volumes. Dalton did not consider the existence of molecules. Question 22. One of the statements of Dalton's atomic theory is given below. Compounds are formed when atoms of different elements combine in a fixed ratio. Which of the following law is not related to this statement? Compounds are formed when atoms of different elements combine in a fixed ratio. Law of conservation of mass, law of definite proportion, law of multiple proportion, Avogadro's law. Only the Avogadro law in which gases combine in a simple ratio. So this is not consistent with this statement. So the answer is Avogadro's law. Question 23. The following data were obtained for compounds of nitrogen and hydrogen. Compound A, mass of nitrogen in gram 0.5, hydrogen 0.18. Compound B, it is 1 gram 0.0720 gram hydrogen. Compound C, 0.75 gram 0.108 gram hydrogen. If the formula of compound B is N2H2, what are the formulas of A and C? Option 1, option 2, option 3, and option 4. Now this data is consistent with the law of multiple proportion. So we have to find the mass of hydrogen combining with the fixed mass of nitrogen. Let the fixed mass of nitrogen be 1 gram. In compound A, 0.5 gram nitrogen combines with 0.108 gram hydrogen. So 1 gram nitrogen will combine with this multiplied by 2, that is 0.216 gram hydrogen. Now take compound B. Here it is amount of nitrogen is already 1 gram. And 1 gram combines with 0.72 gram hydrogen. In C, 0.75. So 1 gram nitrogen combines with 0.108 divided by 0.75, that is 0.14144 gram hydrogen. The ratio of different masses of hydrogen combining with a fixed mass, that is 1 gram of nitrogen, is 0.216, 0.072, 0.144, and making a simple ratio dividing by the smallest number, the ratio is 3:1:2. So we can assume that in A, 1 nitrogen combines with 3 hydrogen, and in B, 1 nitrogen combines with 1 hydrogen, and in C, 1 nitrogen combines with 2 hydrogen. B is given as N2H2, and in B, 1 nitrogen combines with 1 hydrogen. So we have to multiply by 2 so that A may be N2H2. In A, 1 nitrogen combines with 3 hydrogen, so it is N2H6, and C may be N2H4. And since N2H6 is highly unstable, A will be NS3. So NS3 twice is N2H6. NS3 is ammonia, and N2H2 is dioxine, that is B, and C is N2H4, that is hydrazine. So A NS3, C N2H4. Option 4 is the correct answer. Question 24. the density of a solution is 2.15 gram per ml. Then mass of 2.5 ml of solution in correct significant figure is option 1, option 2, option 3 and option 4. Since density is given, we have to calculate the mass. We know density is equal to mass by volume, and density is given 2.15 gram per ml. That is mass by 2.5 ml. Volume is 2.5. So mass is equal to density into volume 2.15 gram per ml into 2.5 ml. Answer is 5.375 gram. But since we are considering multiplication, this is the least precise value and it is having only two significant figures. So the answer must be in two significant figures. The last digit to be retained is 3 and a digit to be dropped is greater than 5. So it turns to be 5.4 gram. The correct option is 5.4. Which of the following sets of components form homogeneous mixture? Phenol plus water, sugar plus benzene, silver chloride plus water, ethyl alcohol plus water. Phenol and water are not miscible, only partially miscible. And sugar and benzene, and sugar is not soluble in benzene. Silver chloride and water, silver chloride is a precipitate, it will not dissolve in water. But ethyl alcohol and water are completely miscible, so they form a homogeneous mixture. So option 4 is the correct answer. Let us consider some numerical questions. And this is section B. It is only for JEE main candidates. First question, the number of significant figures in 5000.002 in 10 raised to minus 3 is. First we have to write it in the scientific notation. So if we write it as the 10 raised to minus 3, therefore the decimal point moves 3 places towards left. So it is 50.00020. So all these zeros are significant, and these zeros and this one also, that is towards the right of the decimal place. So this zero is in between digits. So altogether there will be 8 significant figures. Find the mass of a rectangular piece of copper 24.4 centimeter into 11.4 centimeter into 7.9 centimeter. These are the dimensions. Given the density of copper is 8.92 gram per centimeter cube. We know density is equal to mass by volume. Therefore, mass is equal to density into volume. Therefore, mass is equal to density, that is 8.92 gram. Volume is length into breadth into height. Therefore, this will give the volume of the rectangular piece of copper. So the answer is this one. Since here we have 3 significant figures, here 3, here 3, but here we have only 2. So the answer should be in 2 significant figures. So when we write it in scientific notation, the number to be retained is 9 and this number is greater than, this digit is greater than 5. So this becomes 2.0, that is 2.0 into 10 raised to 4, 1, 2, 3, 4. 2.0 into 10 raised to 4 gram. Phosphorus forms 2 compounds with the chlorine. In the first compound, 1 gram phosphorus is combined with the 3.433 gram chlorine, and in the second 2.5 gram phosphorus is combined with the 14.308 gram chlorine. Show that this data is consistent with law of multiple proportions. The law of multiple proportion, if 2 elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other are in the ratio of small whole numbers. In compound 1, 1 gram phosphorus combines with a 3.433 gram chlorine. In compound 2, 2.5 gram phosphorus combined with this much chlorine. So therefore 1 gram phosphorus will combine with the 14.40 by 2.5, that is 5.732 gram. So in compound 1, 1 gram combines with the 3.433, and now in the second compound 1 gram combines with the 5.732 gram. The ratio of different mass of chlorine combining with 1 gram phosphorus is this divided by this one, 1.670, or the ratio is 1 is to 1.670, and if we multiply by 3, it is approximately 3 is to 5, and a 3 is to 5 is a similar ratio. Hence the law of multiple proportion. Thank you for watching. We will meet in the second part, that is part 2 basic chemistry.